Hi everybody, I'm the greatest living inventor, and today we are doing my invention, Locust Pied Piper of Hamelin. Okay, so let's get started. Locust. Locust, you know also from the Bible, it's the grasshopper when it's in big groups, and it eats all the grain, all the food, all the plants in the field. So that's locust. Pied Piper. Of Hamelin. If you don't know, there is a fairy tale about a little town in Germany that had a problem with rats, and they called someone to take the rats, and he had a magic flute like a piper, and when he played, all the rats came after him, and he went with leading them to the sea, and they drowned. And after this, they don't want to pay him, the people in the town, and he does the same for the kids, for the children. So we are doing the same here, but with the locust, okay, in this invention. Okay, so serotonin affects grasshoppers. Okay, so this insect is really grasshoppers. Okay, it's an insect. It looks like this. It has wings, and it has six legs, and the back legs are big. Okay, so let's say okay, these are the back legs. Okay, and this is a grasshopper, and if it's in big quantities, then it becomes bad. Okay, it becomes locust. Okay, but it's the same insect. Just I'll explain how it happens. Okay, the problem. When solitary grasshoppers get very crowded, their body produces the chemical serotonin. Okay, serotonin. That you know, it's something in our nerve systems, in the brain also. That is a neurotransmitter that comes between, there is if this is the end of one nerve cell, okay, this is a nerve, it's called axon, and this is another nerve, this is the end of one nerve, and this is a long nerve. And here is the beginning of another nerve that goes there. Okay, so this is also another nerve. And between them, this is called the synapse, the connection between two nerves. Okay, and there is a gap. Okay, in the gap there is neurotransmitters. Okay, here. Here there are receptors that are waiting to catch something. And here, and from here there is also openings that normally the serotonin comes through and is accepted by the next nerve. Okay, this is, and this also comes through, and they transmit the message. Okay, but and when there is too much serotonin, this is the serotonin. And it's like a messenger that's going from one nerve to another. And when there is too much serotonin, there is something here, I don't remember the name exactly, something like VMAT2, that you can see in Wikipedia in MDMA. Okay, this whole thing, you have a picture in Wikipedia in MDMA. Okay, which is a drug. We will talk about it shortly. So in here, there is something that takes away the serotonin if there is too much. Okay, so it knows how to accept the serotonin and lock it inside. So normally, what will happen if there is too much serotonin? Then this box takes them and puts them here. Okay, like it locks them inside the box. Anyway, it takes away the serotonin, like there is no serotonin afterwards here. But this box also has it's like also a receiver, okay? And let's draw it here in okay, this also has a mouth that wants to take in serotonin, but if the normally it takes serotonin into here, this box, and after this takes it inside. Okay, but if the MDMA comes, okay, this is the MDMA. Okay, I don't know if you can see the color, it's another color, it's green. Then the MDMA comes to here. Okay, this is the MDMA. And it sits in the mouth of the box and doesn't move. So the box cannot work anymore. It cannot take the serotonin away from the nerve. So there is a lot of serotonin here that accumulates, and no one can take it because the box cannot work anymore because of the MDMA. The box is called something like VMAT2, I think, something like this. So, okay, so this is basically what the MDMA, the drug, does. And this is the serotonin that makes the grasshopper bed, that makes it a locust. Okay, so you have a rough idea. But this is not important for the invention. You just need to know that there is a serotonin, and the MDMA makes, it's like it makes a lot of serotonin. Okay, it's more complicated, but now you know that MDMA causes a high level of serotonin in the brain, in the nerves. Okay, both in people and in grasshoppers. Okay, so we wasted 11 minutes on this, but it's important. It gives you background. Okay, so I'll take off my jacket. Okay, so the problem. When solitary grasshoppers get very crowded, their body produces the chemical serotonin. And this starts to act like, and they start to act like locusts, the bad kind. Fly in huge swarms and eat everything in their path. There are two ways to fight them today, chemical and biological. The chemical is poisoning them, and this costs a lot and hurts the environment. The biological is infecting them with fungus, but it takes days to kill the locusts. In the phrase of carrot or stick, all the current and problematic solutions attack the locusts with a stick. My solution is tempting them with the carrot. Okay, locusts are guided by chemicals. So our next headline, title. So remember, serotonin, MDMA makes the body make a lot of serotonin. The body cannot take the serotonin that is the surplus of serotonin away. Okay, so our next headline, locusts. Are guided by chemicals. Then I read an article in the website of Food and Agriculture Organization of the United Nations, FAO. I will put the link in the description of the video, about biological control of locusts, new weapons for old enemies. Okay, biological. Okay, it's the name of the article, biological control of locusts. New weapons for old enemies. Okay, I'll give you the link in the description. So when the locusts are young, they are called hoppers. They don't have wings yet, so they walk on the ground. They also make swarms and eat crops, but a research team has identified and synthesized a specific locust pheromone, a chemical signal, that can be used against young locusts with devastating effect. So this is all in this article. This chemical called phenylacetonitril or maybe I'll do it in big letters, in capital letters, acetonitril. Or in abbreviation PAN. Is used, so this chemical called the PAN is used by adult male locusts when they mate to deter other adult locust males. It's like a deterrent. But when this chemical is sprayed on the young hoppers, it stops hopper bands dead in their tracks and make them break ranks. Okay, they are no longer in the same line. PAN caused the young hoppers to resume solitary behavior. So it turned from locusts to grasshoppers again. Confused and disoriented, some lost their appetite altogether, while others turned cannibal and ate one another. Any survivors were easy prey for predators. So this, of course, has the problem that you have to locate them when they are young. But this gave me the idea that the locusts are affected mainly by chemicals or smell. The paper talks about a satellite of the French Space Agency that might be able to track them early on. But I invented a solution that doesn't need this. Okay, MDMA creates serotonin so we can guide the adult locusts. Okay, so our next phase in my invention . MDMA creates serotonin . Okay, MDMA is what we painted in green. Remember? This is the green stuff, and serotonin we painted in light blue. Can you see the colors? Yeah, a little bit. Okay. MDMA creates serotonin, so we can guide the adult locust. So we can guide the adult locust. Okay, so this is the main idea of the invention. I'm sure you heard of the drug ecstasy, or in its real name, MDMA. Okay, so this is also called ecstasy. Which I'm sure you know is a drug. The effects are similar on people, and if you don't, then you can read in Wikipedia MDMA. Okay, so this and this is the same thing. It's another name for this. The effects are similar on people. They like to be in big groups, okay, called rave or dance parties, and it's a stimulant that lets them dance for hours, like the insects can fly for hours. Okay, it's also depressing at first the appetite, and you can tell me, wait, but the locusts have a lot of appetite, but yeah, after they fly for hours, they waste a lot of energy. They need all the energy they can get. They are very hungry afterwards. But okay, so it's the same in people. After this, they need food. Okay, after dancing for hours. So the effects are similar on people. They like to be in big groups called rave or dance parties. So in Locust it means big swarms. Sorry. That lets them dance for hours, like the insects can fly for hours. You can see in the pictures here, okay, this is in Wikipedia in MDMA. It's basically what I drawn for you here on the board. How the MDMA binds to serotonin transporters, which means the MDMA ties down and interrupts the work of the part of our body that takes away the serotonin, that lock the serotonin in the box. The box is what they mean. So the result is that the serotonin stays in the receptor all the time because of the MDMA. So if we take MDMA and spray it in front of the flying locust swarms, this is like spraying a very nice scent that they want to follow. We need to affect the leaders and the rest will follow them. So you're starting to see what I mean, Pied Piper of Hamelin. We know that insects can get addicted to drugs too, like people. So their neurotransmitters work in a similar way. So I give you a link in the description to Smithsonian Mag website. There is an article, junkie ants show insects can be addicts too. Okay, if it turns out that the MDMA is not tempting enough, we can tempt them with smell of food or sex, in parentheses, female locust hormones, close parentheses. Or, supposing they follow the other locusts by smell, then we can use for the leaders dust of grounded locusts, and they would turn the leaders into followers. I'm sorry, I know it's disgusting, but we are preventing many human deaths here. Okay, now I'm erasing this and go to the next part. Okay, and the next part is airplanes that work in shifts deploy drones that work in shifts. Airplanes that work in shifts. Okay, so one airplane works, and then when it's finishing the shift, another turn, the turn of another airplane to come, and they come every time another one replaces this is the shifts. So airplanes that work in shifts deploy drones, drones that work in shifts. Okay. So inside the airplanes there are many drones. So we spray a continuous or period stream of the chemical ahead of the swarm, the scent that they like. This can be achieved with drones that are deployed from an airplane. And when their electricity or their stock of chemical is depleted, whichever comes first, the drones return to the airplane to recharge and fill up with fresh stock of the chemical. The airplane itself, when its fuel or supply is running low, can signal or fresh electricity, whatever it needs. The airplane itself, when its fuel or supply is running low, can signal the next airplane to come and take its place. Shifts. The cost of the damage of the swarm of locusts is much more than 2 airplanes and a few drones. In the case that the locusts need also a visual stimulus or guidance from the sun's position, we can make a plastic model of the insects on each drone, but like plants already discovered, for example bee orchids, which are called Ophrys. You can look in Wikipedia in Ophrys. It's a plant, it's a flower that looks like a little bit like a honeybee, and it fools the honeybees, which is another insect. It's not it's not the locust, but it's another insect, so insects are similar. So it fools the flower, fools the insect with the scent, the chemical that the pheromone or whatever love chemical that makes the insect come and mate with the try to mate with the flower. So they don't care much about what they see, but about what they smell. So it's the same, I hope, with the locust, and we've seen that they are very affected from scents chemicals. Okay, so insects can be fooled by smell, which again means putting the right chemicals in the air. If we want to fool the insects about the position of the sun, it is also not very hard. They don't fly at night, and for them the sun is simply the brightest thing that they see. So we can keep a reflection of the sun using larger mirrors, again carried by drones, in some distance from the swarm, and we can fool the leaders of the swarm to follow our fake sun. Okay, we make a fake sun, not the real sun, a fake sun, which will be brighter than the actual sun because it's closer to the swarm than the actual sun, so it looks bigger to them. Just like insects are attracted to artificial light at night, they are hardwired to navigate by the moon and try to keep a constant angle to this new artificial moon, which is a lamp or whatever, and so they get closer and closer in circle to the lamp. So again, insects are easy to manipulate with external stimulus. Okay, so what time is it? 30 minutes. I'm not drawing the drones. I've drawn a lot of drones, but it doesn't add anything to the explanation. Okay, so if there is the sun, like there is the sun, okay, this is the real sun. And if we have drones, with the mirror, okay, this is of course we can make the mirror from many drones that concentrate like we do in solar plants. But if there is the insect flying here, okay, so it's the same insect that we've seen before. Okay, now flying. And if they see the sun far away, and they see this fake sun close by, and we can concentrate again a few drones next to each other, so each one carries a small part of the mirror. So this mirror becomes fake sun. Okay, which is well, it's not, it's really fake. So the insects can be manipulated with the drones also. Okay, so the last part of my invention, I'm erasing this. So the last part is take them for many spins above the sea or deep desert. Take them for many spins above the sea or deep desert. Okay, so if we have an area with crops, and we don't want the locust to be there, then we can take them to either to the sea if there is a sea close by, or to the desert if there is a desert close by. Okay, this is desert. And this is the sea. So we fly with our drones, okay, and our airplanes. Either to here, and we make loops here, or to here, and we make loops above the sea. As much as needed. We can do this infinitely because we change airplanes and the insects don't change. They are the same insects. Okay. At first, I thought it's enough to lead the locust into the sea and they will drown there or get tired and eaten by fish. But it's not so simple. Here is what the FAO article tells us. Okay, the FAO. The same article that we talked about before. During the 1988 desert locust plague, swarms crossed the Atlantic from Mauritania to the Caribbean, okay, from Africa to almost America, flying 5,000 kilometers in 10 days. Scientists were stumped because migrating swarms normally come down to rest every night. But locusts cannot swim, so how could it be? It turned out that the swarms were coming down at sea, on any ships they could find, but also on the water itself. The first ones in all drowned, but their corpses made rafts for the other ones to rest on. Okay, so I'm not drawing this, but they can cross even a sea. So amazing. But anyway, the method we talked about can take them in circles for weeks. Okay, so we can go like this for as long as needed. They can make rafts here, but eventually they will die. Anyway, the method we talked about can take them in circles for weeks, if needed, until they run out of energy and cannibalize each other. And when this resource is gone too, then they will all die. Okay, so this is my invention, and I hope it was clear, and I'll see you in my next invention. So thank you very much. Goodbye. Thank you.